everyone, thank you so much for coming to this video. So today we're going to be introducing linx as a function. So the learning objectives for today is to know and use the definition of log ax as the inverse of a to the power of x, know and use the function of linx and its graph, and know and use linx as the inverse function of e to the power of x. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. It'll be really useful if you just review what we did on e to the power of x and its graph, as that will come into use here. But let's get started. So if we move on to the first learning objective, about getting what the inverse of a to the power of x is. So to do that, if we just call f of x as a to the power of x, so then in order to find the inverse, if you remember, the first thing you do is you just say y is equal to a to the power of x, and then if you using the rule that whenever you have y is equal to the a to the power of x, you could just work out as x as just being the log of a to the power of y. So we've arranged that to get x is something. So this is using log rules, and then you can just replace x as f of the inverse of x, and you just replace y as x. So you'll just get log a to the power of x. So that's how you get that the inverse of a to the power of x is just log a to the log a base a and x. So then if we were to draw the graph of this, so if you remember y equals a to the x, that looks like this, with go across 1. So this is y equals a to the power of x. So remember, in order to draw the inverse of a function, you just want to reflect it in the line y equals x. So if we do that and we reflect it, we should get something in the form of, with passing through 1, so it'll be in the form like this. So that's basically just an overview of the function y equals ax and its inverse, which is y equals log ax. So now that we've done the first objective, let's move on to the second one, which is to know and use the function of linx and its graph. And we can merge that in with this second one, which is to know and use linx as the inverse function of e to the power of x. So as this one says, if we have f of x is equal to e to the x, then that means the inverse of f of x, that's just equal to linx. So that's just the definition, and ln is just the natural log. So yeah, so basically all you need to know is that the inverse function of e to the power of x, that's just ln of x. So we can use that to graph ln of x. So if you remember, the graph of e to the x looks like this, going through 1. So this will look really similar to what we just did with a to the power of x, because if you remember, e to the power of x is just a version of the graph a to the power of x. So then, because it goes through 1 and 0 here, and that means ln of x will also go through 1, 0. And if you were to reflect it in the line y equals x, the graph would just look like something like this. So this is ln x. So there are some key definitions that you need to know. The first one is that it goes to the point 1, 0, as I said before. So that just means that if you do ln of 0, you just get 1. And then the next thing is that if you, as x approaches infinity, ln x would also approach infinity. So you can see that by, as you keep on going, as you increase n, ln x would just keep on increasing and increasing and increasing towards infinity. And the next one is that as x tends to 0, so as x tends to 0, ln x, that tends to minus infinity, but it will never ever reach it will tend to infinity, but it will never reach the y-axis. So this means that you can never have a value of ln x that is 0. So ln x can never be 0, and ln x can also never be less than 0. It cannot be negative, so it can't be this. So that's like a definition of ln x that you should remember, that ln x will never equal 0, and ln x would also never be negative. It is always positive. So that's everything you really need to know about what ln x is and how it's the inverse. So just remember that ln x is the inverse of e of x. So to draw its graph, you just reflect it on the line y equals x. And then the key definitions you need to know is that ln 0 is just 1, but it can't be 0 and it can't be less than 0. So that's the second learning objective done. So we have a question here. We want to solve the equation ln 2x plus 5 is equal to 1. So feel free to pause the video and try it out for yourself. So in order to solve this, we can use that the cool property that ln x is the inverse of e to the power of x and vice versa, which means that if you do e to the power, if you do e then ln 2x plus 5, and that's just equal to e to the power of 1, then this would cancel, which means you would just get 2x plus 5 is just equal to e. And then you can rearrange this, and then you'd get 2x is equal to e minus 5. So then x is just equal to e minus 5 over 2. So this is just using the property that because e to the power of x and ln x are inverses of each other, if you do both of them together, so it could work either way. If you do f of inverse x, so if you do e to the ln x, or then if you do the inverse x times f of x, so then if you had you could do ln of e to the power of x, both of them would just equal x. So here we just did e to the ln of 2x plus 5, so that would, using this, that would just cancel out to whatever power you have, whatever x term is. So that's just 2x plus 5. And remember, whatever you do to one side, you have to do to the other side. So then we raised e to the power of 1, and then we just rearranged it, and we got our answer for x. So that's everything. Thank you so much for coming to this video. So hopefully that was useful, and you now understand that a to the power of x is its inverse is just log ax, and that ln x is the inverse of e to the power of x, and you can use this definition to solve some equations. So make sure you do some more practice questions just to make sure you fully understand everything we covered. But thank you.